AP Calculus BC, Unit 6, Day 5, Office Hours. So here's some free response questions involving slope fields, differential equations, maybe exponential growth, logistic growth, all sort of problems that could show up on this kind of free response problem. So differential equation on the axis, sketch the slope field of the given differential equation at 12 points. I always try and make a point of noting that so I don't do too many or not enough. So sketching it, I'd figure out, well, where does it equal 0? That's going to be x equals 0 and y equals 2. So x equals 0 is the y-axis, so 0, 0, 0, 0. Y equals 2 would be right here. And we just got half of the points done. Other than that, there might be some symmetry. You might start plugging some 1, 0 in. Is going to be negative 2. Negative 1, 0 is going to be also negative 2. 1, 1 is going to be negative 1. Negative 1, 1 is also going to be negative 1 because the x gets squared. 1, 3 is going to be positive 1, and negative 1, 3 is also going to be positive 1. So kind of more of a symmetry across the y equals 2 line. Okay, so out of the 9 points that this problem is worth, that would be 2 points and probably be 1 point for all the 0 slopes and 1 point for all the non-zero point slopes. If you mess one up, you lose all the points. Okay, while slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all the points in the xy plane for which the slopes are negative. So I mean, you look at this, you say, oh, they're negative here and here, but this graph, this slope field goes on forever. There are no values that it's not defined at. And so we need to describe all the infinite places where this is true. Now, you might get a rough idea from the graph, but I wouldn't rely on that. I would do some algebra here. I'd say, okay, well, where is the slope dy dx equal to x to the fourth, y minus 2, negative, less than 0. And I say, okay, well, this guy is never going to make it negative because it's always positive, right? Because it always gets raised to an even power. Except x can't be 0 because then it's not going to be negative anymore. So really, it's relying on this to be negative. So I would write that, in the form of an answer. There's a couple ways we could describe that. We could say, the slopes are negative at all points x, y, where y is less than 2 and x doesn't equal 0. So that's one way you could answer it. Or you could answer it a little more visually. You could say all the points below the horizontal line y equals 2, but not on the y-axis. So that describes the same thing. So, okay. C says to, and by the way, this was 1 point. So that means we got 6 points left for solving the initial value problem, which I feel like is a very predictable, sequence of steps that we're going to take. So C equals, we have to separate the variables, which is usually worth a point. And if you don't do it, you get no points. So critical, 1 point, but if don't, then you get minus 6 points. All the rest of the points you lose. Separate the variables, integrate both sides, natural log the absolute value y minus 2 equals x to the 5th over 5. So these antiderivatives are worth 1 or 2 points. 1 or 2 points usually. Plus C is worth a point, constant of integration. If you don't put this, you lose all the rest of the points. If don't, minus 3 rest of points. So, and then you're going to find the C value. I would do that right now. Natural log the absolute value of y minus 2 equals, and use the initial condition, which they give us down here, 0, 0. So we plug 0 in for y and 0 in for x. And so C equals natural log of 2. So that's a point, usually. So we re-enter it, rewrite it, put our C value in there. Now, solving for y, the rest of the work is worth like 1 point usually. It's all algebra. It's probably the messiest part of the work. You want to get rid of the absolute values. You can do plus or minus. I'm going to use rules of exponents to break this up. So that's going to be 2 e to the x to the 5th over 5. We could add 2. Now, I would determine if it's positive or negative right now. So if you plug 0 in, you should get 0 out, which means if this is 0, it's going to get negative 2. You actually want the negative version. I feel like so many times we end up with the positive version, but this time it's actually the negative version. So hopefully you wrote plus or minus, and hopefully you thought through. So that's the solution. Now you also need to do the domain for the domain. And there's two things you need to consider. The domain of this, which is all real, so that's fine. And the domain of the derivative. Are there any values of x or y that would cause problems? Division by 0, logs of 0 negatives, even roots of negatives. Nope. So we're good. Single open interval of every possible value, all real numbers. So that's it. And you need to put the domain. Okay, number 5, differential equation. On the axis, slip the sketch the slope field, 9 points. So I'm going to first say, well, where is it equal to 0? And that's going to be when y equals 1, 0, 0, 0. And also when cosine pi x equals 0, which is going to be pi x equals pi over 2 plus pi k. So that's going to be x equals 1/2 plus 1k, which is nice, except that doesn't give us any of the points. That gives us like 1/2 and 3/2, and those aren't places where they put dots at, so we're not going to do any of those. So we need to just plug some other values in. 0, 0. Cosine 0 is 1, and negative 1 squared is 1, so you get positive 1. 1, 0. Cosine of pi is negative 1 times positive 1, so it's going to be negative 1. Negative 1, cosine of negative pi is negative 1. And this is going to be negative 1 squared. So it's going to be negative 1. And then 0, negative 1. Cosine 0 is 1. It's going to be negative 2 squared is positive 4. And then 1, 1. 1, negative 1. Cosine of 1 is, pi is negative 1. And then negative 1, that's going to be negative 2 squared is 4. It's going to be negative 4. And then negative 1, negative 1. Cosine negative 1 is negative 1. Negative 1 minus 1 is negative 2 squared is 4. It's going to be negative 4. It's going to be kind of steep. So there you go. 2 points. Probably 1 point for the 0 terms and 1 point for the non-zero terms. Okay, B says there's a horizontal line with the equation y equals c that satisfies this differential equation. Find the value of c. Now, just looking at the picture right here, this appears to be the horizontal line, right? It's going to be probably like horizontal asymptote unless you pick value right on it, then you're going to stay on it. So the line y equals 1 satisfies the differential equation. Okay, so it says find the value of c. So c equals 1. So c equals 1. Right? Y equals c. Find the value of c. C equals 1. As far as like solving that, let's say for part B, I'll do another version. If it's a horizontal line, then you know the slope has to be 0. So here's the algebraic way of doing it. Slope has to be 0. So you're going to set your slope equals 0. In fact, we already did this up there. And so that means y minus 1 has to equal 0. And cosine pi x has to equal 0. So that's going to be y equals 1. Hey, same result. Horizontal line. Pi x equals pi over 2 plus pi k. X equals 1/2 plus 1k. These are vertical lines. So that's the horizontal line. Okay, C, find the particular solution of the differential equation with initial condition 1, 0. So I'm going to do the work here. So this is, this was, part B was 1 point. Part C is 6 points, bunch of points for solving the differential equation. So I'm going to do part C up here. We're going to separate the variables. You can integrate both sides. So that's a point just for separating the variables. I'm going to rewrite this as y minus 1 to the negative 2 dy. You could use u substitution for both sides, but I think it's both pretty simple. So the antiderivative of this is going to be y minus 1 to the negative 1 divided by the negative exponent. The inside, the derivative is 1, so you don't need to do anything extra. This one's going to be sine of pi x, but the chain rule is going to put another pi out in front, which we don't want, so we need 1 over pi. That's what the chain rule would do for you. Now I'm going to rewrite this with positive exponents just because I feel like that's easier to work with. Let's find the c value right now. So the antiderivatives were probably 1 or 2 points. And then the plus c value is 1 point. And then finding plus c is going to be another point. So if we plug 0 in here, sine of pi. Now sine of pi is 0. This is going to be positive 1. So c equals positive 1. So that's another point. So they're going to rewrite it. Negative 1 over y minus 1 equals 1 over pi sine pi x plus 1. Now, what I want to do, I kind of want to flip both sides. So I got to put this all as one big fraction. So I got to give this guy the least common denominator. And then I could flip both sides and then multiply the other side by negative. So I get y minus 1 equals negative pi over sine pi x plus pi. You can't just flip each fraction separately. It's got to be one fraction and one fraction. That's the only way you can do it. It's the only way it makes sense. So now we're going to add 1 to both sides. And so our equation is 1 minus pi over sine pi x plus pi. Now domain, the derivative doesn't have any issues. That makes it undefined, but this potentially does. We need to check it out. Sine pi x plus pi equals 0. So that's going to be sine pi x equals negative pi. What are the values that make that happen? None. Impossible. Because you guys are very aware that the range of sine of anything is between negative 1 and 1, and that's equal to negative 3.14. That's just not possible. The sine curve is this curve that goes between negative 1 and 1. It's never going to get to negative pi. So we're good for the domain. It's all real numbers, negative infinity, positive infinity. You have to give the domain. And your test, you're going to lose credit. So there you go. That's that. Got one more on the back. Okay, so this says let function f4 equals 1, all points satisfy the differential equation. And then G, that's F, and then G has a initial condition, satisfies the logistic differential equation. This one's not logistic. This one is. Okay. So part A says to find y equals fx. So part A is we're solving that differential equation. That's not the logistic one. So we need to separate the variables. I'm going to distribute the 2 into that. 6 minus 2x dx. So that's probably a point. Integrate both sides. Natural log the absolute value y. 6x minus 2x squared over 2 plus c. That's probably a point. Point, another point. Find the c value right now. Natural log of 1 equals 6 times 4 minus 4 squared plus c. This is going to be 0. So 0 equals 24 minus 16 plus c. 0 equals 8 plus c. C equals negative 8. Another point. Let's rewrite it. Natural log the absolute value of y. 6x minus x squared minus 8. We got to solve for y. So we're going to exponentiate both sides. I'm going to get rid of the absolute values, plus or minus. We need to decide if it's plus or minus right now, and it can make a difference, as we just saw in problem not that long ago. If you plug a 4 in here, it's going to be 24 minus 16 minus 8 is 0. E to 0 is 1, and we want it to be positive 1. So this is going to be your solution. We need to check out the domain. Any issues here? Nope. Any issues with the original differential equation? The derivative being undefined for x or y values? Nope. So for domain, negative infinity to positive infinity. You gotta check both those places, your answer and where it came from. So that's A. B says, given that G4 equals 1, find the limit as x approaches infinity of gx, and also the limit as x approaches infinity of g prime of x. It is not necessary to solve for gx or to show how you arrived at your answers. You can just write the answers down. Now, this is the logistic one, right? So I'm gonna write this down right here. Dy dx equals 2y 3 minus y. And I'm going to write down sort of the memorized version, 2k, sorry, it's ky m minus y. So this is your k value, and this is your m value. What happens to the logistic curve when you go to infinity? It approaches the carrying capacity. Done. What happens to the slope as you go to infinity of the logistic curve? It approaches 0 because the growth levels out. Done. That's all you needed to do. All right. C, let's see. C says, for what value of y does the graph of g have an inflection point? Find the slope of the graph of g at the point of inflection. It is not necessary to solve for g of x. Hint, hint, please don't. So you're looking for the inflection point, right? And we know that it happens at half the carrying capacity when the y value equals half the carrying capacity. And the carrying capacity we just wrote was 3. So this is the y value where we get the carrying capacity, right? And then it says to find the slope there. Well, the slope is dy dx, which equals 2y, 3 halves, times 3 minus y, 3 halves. So you don't even need the x value. Okay. Least common denominator is going to be 2, so that's going to be 3 times 3 halves. So dy dx equals y equals 3 halves equals 9 halves. That's where it pays off to know logistic growth, because alternatively, here I'll show you, alternatively, you could have solved the differential equation for part B, found the solution, and then took the limit. I mean, it's a ton of work. You're probably going to mess up. You probably don't have time either. And by the way, the points on that are worth 2 points total. So all this work, that's 1 point. And then you would take the derivative of this unnecessarily and then take the limit as x goes to infinity. That'd be 1 more point. You're probably not going to pull it off. Part C, you could have looked for the inflection point by doing the work to find the second derivative and so forth. But or you could just memorize that it's at half the carrying capacity. So sure, there's ways to do a lot more work on this, but I don't think you want to do that. This was 5 points, 2 points, and 2 points. So let's know logistic growth. If you know it, the work gets really easy on the A/B test usually. The alternative, the hard way, is if you don't really know logistic growth well, and if you just try and do it the way you would any other problem. That's it.